Alright, so here's the problem we're dealing with on uniform circular motion. Number 63, probably you're going to think it's one of the easiest problems to solve, but the trick to it is you have to be able to think about the forces going on in the problem. So for example, reading from page 172, number 63, a 75 kilogram pilot flies a plane in a loop as shown in figure 23. At the top of the loop, when the plane is completely upside down for an instant, the pilot hangs freely in the seat and does not push against the seat belt. The airspeed indicator reads 120 meters per second. What is the radius of the plane's loop? So this is what I've done up here on the board. I've drawn this loop with a radius and a velocity coming out tangential to the circle and perpendicular to the radius. This is the key. The only information they give you is the mass of the pilot, and they give you the velocity that the jet's traveling at. You have to think about the instance where it says the pilot hangs freely in the seat and does not push against the seatbelt. There's no force. The net force overall in that case, that sentence right there tells me that the net force overall in that case is 0. Why? Because all the forces acting on it they're in opposite directions, magnitude, all that stuff. They cancel out and give me 0. Because he's sitting freely. And a jet's going really, really fast. So there should be some forces going on, but since there's not, that tells me that it has a net force of 0. So net force equals 0. Now that's for the whole thing. So we're trying to figure out the radius of the circle. This is the key to getting your answer, and this is why. What forces are acting on this pilot and the jet? You have the centrifugal force, everything taking place here in the actual loop. But what else is happening? It's the force of gravity. So, if you add these together, there's your net force. Now this means one thing. They have to be equal magnitude but opposite direction, which is good for us. This is one easy, simple fix. If you go to your formulas of what you're thinking about, jump straight to the formula of acceleration. Centripetal acceleration is equal to the velocity squared divided by radius. I'm trying to find radius. Do some algebra, you'll find the radius is equal to the velocity squared divided by the centripetal acceleration. Now, you have this. You know velocity. You have to find acceleration. And this is what it is. Velocity is 120 meters per second squared divided by 9.81 meters per second squared. How did I think of gravity? This is why I thought of gravity. What do we have here that's going on is gravity. That's the acceleration in this case. Gravity's here, but then we don't know the centripetal acceleration, but we know that our net force is 0. Since the net force is 0, that means that our centripetal acceleration has got to be equal to the same acceleration for the force of gravity. The reason why is because the masses are the same. The only thing that's changing would be accelerations. So, it's got to be gravity. If you do this, you'll punch that in a calculator. And you'll end up with 1,467.8899 meters. I got meters because meters, seconds cancel. Meters cancel second, leaves with meters. So there's the units for it. These problems, like I said before, they're trickier and they're hard. They're not hard to solve. They're the complicated ones you got to think through. So take some time, Here's 63 for an example. And if you got any questions, just holler at me.